Our next test is on Wednesday this week. It's at 11. The venues are same as for exam 2. I have already posted the study guide and practice problems on Blackboard. Please, if you haven't already practiced the problems, please do so as soon as possible. On one of the problems, I used incorrect angle in my key. I think it's problem number 4, the ladder problem. So on the question it says 45 degrees, but I used 30 degrees and 60 degrees because I had a couple of different versions and I was mixing up the versions. So I used the wrong angle, but now I fixed it. So if you downloaded the previous version, so download it again. I have uploaded the newer version, but just to remind you that the angle in the previous version is not correct. Okay. For your test, again, you will see some problems. For the problems, please go through the practice problems and the worksheet problems. Okay. For quizzes, please review the not quizzes. For the multiple choice questions, please review the quizzes, previous quizzes. And if you guys have any question, yes, feel free to come to my office anytime. Anytime you see my door open, you can knock my door and ask questions. So do you guys have any question about the test or any other things? If you guys are struggling with homework or any kind of concepts, you can always come and talk with me, okay? I'll be more than happy to help with the homeworks or any kind of other stuff about this course. So, do you guys have any question about test or homework or concepts or anything? Look at the study guide. I have posted that on study guide. So which worksheet you want to look at and which quizzes you want to review. So all those things are on study guide. So study guide is on Blackboard. Okay. So it's on week 14 folder. Previously it was on week 13 folder, but now I transferred it to week 14. Any other questions? Okay, if not, then let's look at stability of an object. So we were talking about the stability of an object, the condition for stability last time. And we saw that when the center of gravity of an object is exactly above the midpoint of its base of support, then it's in stable condition. Okay, so this is called stable equilibrium. Again, you see here, this weight is along this line, middle line, and also in this case, the angle between this weight and the height is 0. Okay, because they are along the same line, so theta is 0. And when theta is 0, that's the stable equilibrium. Now when you tilt it, you'll have some angle between H and W. And also this weight is still within the base of support. Okay? If you let go of this object, it will still go back to its original state. It will go back to the stable equilibrium. If you further increase it, it will reach a point where, where the weight is exactly above the pivot. That's the pivot. And as long as you don't disturb the object, it will stay as it is. So this is still equilibrium, but it's called unstable equilibrium. Unstable because if you even slightly disturb this object, it can become unstable. It can topple to the right. Okay, so it's unstable equilibrium, and this angle up to which it's still up to which it can still go back to its stable state is called critical angle. Okay, once you increase the angle greater than that, then it won't be able to go back to the stable state. It will be in a non-equilibrium state. It'll topple to the right. Okay, so any angle greater than theta c, the object will it'll go to the unstable state or non-equilibrium state. So in a real life scenario also, so up to this point, if your car is tilted up to this point, critical point, up to critical angle, your car can still go back to this stable state. But once the angle is above critical angle, then your car will roll over. Okay. Another case where your car rolls over is when this weight is outside this base of support. So this is the base of support, this thing. This length is the base of support. So you see here this weight is outside the base of support. In all these cases, the weight is still inside the base of support. It's inside the base of support, inside the base of support, inside the base of support. But here it's outside the base of support. And once it's outside the base of support, it cannot go back to its stable state. Okay. So how do we increase the stability of a vehicle? We can increase the stability of the vehicle by increasing the critical angle. Okay. Greater the critical angle, more stable a vehicle is. So we need to increase that. And how do we increase that? To increase that, we need to increase this right-hand side. To increase the right-hand side, we need to either increase this numerator or decrease that. What does that mean physically? So increasing T means making your car or vehicle wider. Okay, make it wider. And what does decreasing H mean? Meaning lower the center of gravity. Center of gravity. Okay. Make the bottom part heavier. If you make the bottom part heavier, then the center of gravity will shift down, and as it shifts down, this height becomes smaller. With that, you can increase theta c. Okay. Okay. So let's look at this problem that will make this thing even more clear. This is the problem from worksheet 17. So an object will topple over if the angle between the height of the center of gravity and weight of the object exceeds the critical angle, which we just saw. A particular sports utility vehicle has the base of support 1.8 meters. Base of support is T. I cannot write here. See if I can copy that. So T is 1.85 when there is only a driver in the vehicle, its center of gravity is 0.87 meters from the base of support. So h is 0.87. Okay. So that's h, that's t. So at what angle the SUV roll over if it is tilted in an accident? So we know that the SUV will roll over if the angle of tilt is greater than critical angle. So if we can find critical angle, then we know at what angle it will roll over. So we need to find theta c, and theta c is given by tan inverse T2H. Okay, that's the formula for theta c. So tan inverse T is the base of support, or the base of the car, width of the car, which is 1.85 meters, 2 times height is 0.87, and that gives us what is that, 46.3. Okay, 46.3 degrees is the critical angle. So at any angle greater than 46.3 will put the SUV in non-equilibrium state. Meaning it will roll over when the angle exceeds 46.3 degrees. Okay, so that's part A. For part B, let's see what part B is. So what do you think will happen to its stability when you load some weight on the roof rack of the SUV? Why? So you have this SUV, okay, and you put some weight on the top here. So what will happen to the stability?
It'll decrease the stability.
Yeah. Why is that?
You're increasing the height.
Yeah, exactly. So basically the center of gravity is shifted up when you put more weight on the top. Okay, so initially when there is no weight here, let's say its center of gravity is here, but as you put more weight here, the center of gravity would be shifted up, and because of that this height increases. Okay, and when height increases, we know theta is tan inverse h sorry, not h, t 2h, t over 2h. So that means increasing this decreases that, and decreasing that means decrease in stability. Okay, so you need to put that in words. So you can say that increasing weight on the top increases or shifts the center of gravity up, that means h increases, and as h increases, theta c also increases, theta c decreases with that formula, and theta c decreases means it's less stable. So actually this answers both these questions, B and C. Okay. So now let's consider a new center of gravity, which is 0.95 from the base of support. So what is the critical angle in this case? At what angle will it roll over? So we want to find theta c for this one. So tan inverse T over 2h. So tan inverse T. T is same, okay, it's the width of the car, which is 1.85. 2 times now height is changed, which is 0.95. So do the calculation. You get 43.76 degrees or 43.7 degrees, which is less than the previous one. Okay. So the previous one was 46.3. Here it's 43.7. So that shows that it's less stable. So this will tilt, it will roll over when theta c, when angle is greater than 43.7 degrees. Okay. That's 2. Now I would like you guys to do number 4. Okay, it's exactly same problem. So let me put the question here, and then why don't you guys tell me the answers? It's pretty straightforward. Just use that formula. So tell me what theta c is for this one. Okay, so Cameron said it's 56.5 degrees. So do you guys have same answer or different answer? Okay, that's good. So based on this calculation and the previous problem, which vehicle do you think is more stable? This sedan car or SUV, an SUV? So for sedan, theta c is 56.5. For SUV, theta c, what we got?
The sedan car.
Yeah, exactly. So we see that theta c is greater for sedan than for SUV. That's why it's more stable. So you need to think twice when you are buying SUV then, okay, if you are looking for a stable, more stable car. Or try to buy one that has lower center of gravity. Or do not put too much stuff on the rooftop on your SUV if you want to make it more stable. Or you can put more passenger in the car to make it more stable. By putting more passenger, you lower the center of gravity, and that way you can make it more stable. Okay, so that's worksheet 17. Let's look at worksheet 18. So we talked about linear motion before, and we can pretty much use all those concepts to do the rotational motion problems. Okay. So in linear motion, when we talked about a car moving on a straight road, or when you are walking, when you throw something in air, what are the quantities involved? This is the first chapter we discussed. So let's say you are throwing an you are driving a car on a road. What physical quantities you use to describe the motion of the car? Tell me some of the physical quantities that you use to describe the motion. If someone asks you how you are driving,
Say how fast?
yeah, how fast, meaning speed, right, or velocity. If you also need to know the direction and how fast you are moving, then you use velocity. If you don't care about direction, you just need to know how fast you are moving, then you use the term speed. What else? Whether you are accelerating or not, right? So you use acceleration. What else? How much you traveled. Okay, so displacement or distance. What else? You can say where you are at certain time or position. What else? Whether or not something there is some force or not, okay, on the car. Okay, so these are the quantities that we use to explain the car. Also, we can say how heavy your car is. Okay, so you can explain your car with mass. Now we can use similar kind of quantities in case of rotational motion. Let's say you have a sphere or a ball or something, a round object, and it's revolving around its axis. So this is the axis, some imaginary axis, and you are rotating this object in its own axis. So it's also same kind of motion, like a linear motion, but here we use a little bit different kind of physical quantity. So for speed, speed of how fast it is revolving. Instead of calling speed, we call it angular speed. Okay. For acceleration, how fast the angular speed is changing, we use the term called angular acceleration. For displacement, it's just adding angular on all these things. So angular displacement. Okay, this is for rotational motion. Angular displacement. Angular position. Just add angular in front to all these linear parts. Force, you cannot say angular force. Instead of angular force, we say torque. Okay. So in case of linear thing, when you push it, you're applying force. But here, when you push this in such a way that it rotates, then you say you are applying torque. Okay. Torque means something that produces rotation. Mass, no angular mass, it's called inertia or rotational inertia, or it's called moment of inertia. Another thing is we also use momentum. So here we use, in rotation, we use angular momentum. Here we use kinetic energy. Here we use also kinetic energy, but it's angular kinetic energy, potential energy. Usually we don't have angular potential energy. Okay. So what is angular speed? Or what is, even before that, what is angular displacement? Let me first ask you, what are the notations for these things? So speed is what? Do you remember? V, right? What's the notation for acceleration? A. Yeah. Displacement is delta x. Position is x. Force is F. Mass is m. Momentum is P. Kinetic energy is just Ke. Here, speed is, angular speed is this Greek letter omega. Angular acceleration is alpha. Angular displacement is theta. Angular or delta theta displacement. Angular position is theta. Torque is tau. Momentum of inertia is I, or sometimes it's also called mi. Angular momentum is L, and kinetic energy is just K. Okay. So now let's define all these quantities. So let's consider this round plate or something. It's easier to define with this round plate. Okay, this is the axis about which is rotating. Okay. So you can define this horizontal line as a reference line. Okay, so let's say this is the initial position of this particular point. Okay, so it's rotating counterclockwise, and at some time t later, it's now at this point. Okay, so this red line is now at this point. So it started here. This is the zero mark, zero angle, and here at delta t time later, it's at theta is equal to some angle, let's say 30 degrees. Okay? So this angle is what this angular displacement is. Okay? Angular displacement is by how much the reference line is displaced within certain time. And this line, this number is angular position, 30 degrees. If it's here, let's say it's 120 degrees, that's the angular position. Okay? If it's here, it's at 120 degrees, so angular position is not 120. What is the angle? 270 degrees. So that's the angular position. Okay? Angular position is where that reference mark is. And angular displacement is the displacement of that mark from initial point to the final point. So if you guys remember, what is the linear displacement? How do you find linear displacement? That's x final minus x initial, right? So we don't have a new formula here. The only thing we do here is just replace this linear part by angular part. So to find the angular displacement, delta theta, so you replace x by theta. Okay, so xf is theta f, xi is theta I. Okay. Likewise, let's say you want to find angular speed. First, you need to know what the formula of the speed in the linear case is, and then you can replace all these terms by these terms corresponding to the angular motion. So, do you guys remember what formulas we used to find speed or acceleration? I gave you 3 formulas last time. And it depends on whether the motion is clockwise, the motion is uniform or not. Okay, so we have uniform motion, you have non-uniform motion, do you guys remember what uniform and non-uniform are? Uniform is, what kind of motion is uniform? Where speed is constant, right? Speed doesn't change. That means there is no acceleration. Non-uniform is where speed or where velocity changes. So acceleration is non-zero. There is non-zero acceleration. So for uniform motion, there's only one formula, which is V is equal to displacement over time. Okay. For this one, this is the linear part, but for angular motion, so the equation would be V is omega. Okay. If you look at the notations I wrote on the top here, V is replaced by omega, A is replaced by alpha, X is replaced by theta, F is replaced by tau. Okay. You just need to replace these things with the angular counterpart. So V is replaced by omega, so X is replaced by theta, and T is replaced by, there is no counterpart for T, T is T itself. That's for the uniform motion. Now for non-uniform motion, we have 3 formulas. One is A is equal to V final minus V initial over T. That's the first one. Second one is delta X is equal to VIT plus 1/2 AT squared. That's the second one. Third one is delta X is equal to V final squared minus V initial squared over 2A. Okay. Now we can write the angular counterpart of all these equations for angular motion. when we are dealing with angular motion, we can write the equations as A is replaced by alpha, Vf is replaced by omega, V is omega, final is initial, T is T, delta x is delta theta, okay, x is replaced by theta. Oops. And then V is replaced by omega plus 1/2. A is replaced by alpha, and T is T itself. Okay, that's the second equation for rotational motion. And then delta x is delta theta. X is replaced by theta. V final is omega final squared. V initial is omega initial squared over 2. A is replaced by alpha. Okay, so that's the equation for rotational motion. Equation for rotational motion. Now, if I ask you guys, give me rotational motion equation for this one. F is equal to ma. Okay, so this is the linear for linear motion. What is the same equation for angular motion? No idea?
Tau equals mass times
Wait, tau, okay, force is replaced by tau,
tau and then the inertia.
mass is replaced by I, yeah. A is replaced by alpha, yes. Good. Okay, so tell me, what is the angular momentum, not angular momentum, okay, angular momentum. So angular momentum is L. So we have linear momentum is mv. So the counterpart of this one is what? What is the formula for angular momentum?
Inertia times W.
It's omega. Yeah, good. How about kinetic energy? So kinetic energy is 1/2 mv squared. What is the rotational kinetic energy? So usually for rotational we write kinetic energy ROT. ROT means anything that is rotating. So 1/2 mass is
Inertia.
I, yeah. V is omega squared, right? So see, it's pretty straightforward. You just need to know which one corresponds to which one in rotational part. If you know that, then you can just use the previous formula. So for that, you need to look at this table, okay? So the rotational counterpart of speed is omega. Rotational counterpart of acceleration is alpha. Delta x is theta, delta theta, okay, all those things. So let's look at worksheet 19, or is it 18? Worksheet 18. So let's look at number 1. A circular object with radius of 20 centimeters rotates at a rate of 900 RPM. RPM means revolutions per minute. So you have some kind of circular object and it's revolving about its own axis, and it's revolving at 900 revolutions per minute. So it's asking, find the angular speed of the object. We want to find omega, okay, angular speed. And find the tangential speed of a point on the circumference. Let's consider any point on the circumference at that point. So what's the tangential speed? Tangential speed is v. Okay. So first thing is we want to find omega. So the definition of omega is how fast the object is rotating. Okay. Or it's delta theta over delta t. Okay. Just like in linear case, we have v is equal to delta x over delta t. So omega is delta theta over delta t. In other words, this one, if you want to know the literal meaning of that, how much angle it covers in time delta t. So it's rotating, okay, you consider a line like that. So in certain time delta t, how much angle it covers, okay, with respect to that time. That's the, I should also write, yeah, how much, that's fine, okay. So delta theta over delta t. So how do we find that? So we need to do a little bit of arithmetic here. So we have 900 revolution per minute, and we want to express this in angle over time, second. Okay. So usually W is measured in what's the unit of angle? Mm-hmm. What else? What other unit you use for angle? Degree is right. There is very important distinction here. Okay, this is very important. So I want you guys to think about that. Radians, exactly. So when you use degrees and when you use radians, that's very important. So if you have function like sine 30 degrees, cosine 30 degrees, you use degrees, okay, for that. But if you don't have these functions and you only have the angle, then use radian, okay, only angle. Like here, you don't have any function, there is only angle, right? So you cannot use degrees. So in this case, you need to express this in terms of radian, okay? And time is expressed in second. So the unit of omega or angular velocity is radian per second, rad per second. So 900 revolution. In one revolution, how much angle is covered by this reference line? So starting from here, it revolves and then come back to the same line. So how many angles or how much angle it covers? One? Oops. What happened? How do I get rid of that? Any answer for that? No, I cannot get rid of this thing. 365, yes, exactly. But 365 is in degrees. And I said that when you don't have sine, you cannot use degrees. What should be that? Not 1 radian. How many radians is that? Okay, I need to reopen that. Think about it. Okay. So when you make one complete revolution, what's the angle in radian you cover? Starting from this point, rotate, and come back to the same point. What's that angle? Two pi, right? 2 pi radian. In one complete revolution, you cover 2 pi radian. So we have 900 revolutions per minute. So 900, each revolution is 2 pi radian. And now we want to convert minutes to seconds. Okay, so 1 minute has 60 seconds. So 900 times 2 pi over 60 radian per second. That's the angular speed. So let's figure that out. So that's, what's that? 30 pi, yeah, 30 pi. But in terms of number, what would that be? Pi is 3.14. Is that 94.2? Okay. Now, part B. If you consider a point, how fast that point would be moving. So we want to find v. Okay. So how fast this point is moving, this is called tangential speed. Angular speed, this omega is how fast the angle is changing, but this v is how fast a point on that object is moving forward. And the relationship between v and omega is v is equal to omega times r. Okay, that's the formula to get v, tangential speed. So omega is 94.2 and r is the radius. Okay, radius of the circular object is 20 centimeters. So 20 times 10 to negative 2 in terms of meters, and that gives you 18.8 meters per second. Okay, so that's number one. Number two, we only have a minute left. Is pretty straightforward. If you, let me just give you a hint for that, and you can try on your own. So a disk is rotating at 900 RPM. So omega 1 is 900 RPM, and then it slows down until it becomes 300 RPM, and it makes 50 revolutions. So delta theta is 50 revolution. So we want to find alpha, angular acceleration, and we want to find t. So change this to radian per second. Change this to radian per second, and then change this to radian. And then find alpha. So do you guys know the formula for A in terms of the two velocities and displacement? So it's Vf squared minus Vi squared over 2A. So this is for the linear part. Write the exact formula for angular part. Angular part, A is alpha, V is omega, and A is, no, sorry, not alpha here, this is delta x here. 2 times delta x is theta. Okay, so that's the formula for angular acceleration. Okay, I think we are out of time. We will continue this next time, but that's all for now. If you guys have any question about test or anything, please let me know.
Is this going to be on the test?
No, this won't be on test. The test will cover only up to last lecture.